Comfy enough chairs. Yeah, this is
Not
nice.
bad.
Thanks everyone for being here, and thank you both for joining.
Thanks for having us.
Yeah, so I think it's a great time to discuss AI safety and ethics. It feels timely. I mean, not that it ever doesn't feel timely, but like as these models improve and become more capable, and as the technology democratizes or continues to, right? Like, I think it's an important conversation to continue having, right? And factors about the conversation change with each month now, I feel like at this point. So maybe for the audience, we can establish some ground truth, maybe arrive at like a definition of safe AI, right? Like what does it mean when we talk about safe AI? Are we talking about AI with a lot of guardrails, developed transparently, all of these things? So, you know, maybe Artemis, if you want to kick us off, and hopefully we can, you know, go from there.
Sure. Well, it's really, really hard to arrive at a single, simple definition of such a complicated area. I think, simply put, there's two aspects of AI safety, and people use a lot of words: safety, responsible AI, AI ethics. But at the end of the day, it's really about what the models can do that is dangerous, and what humans can do with the models that is dangerous. And each of these pillars has a lot of complexity and a lot to say under it. The bit about the models, which is traditionally what people describe as AI safety, as opposed to AI ethics, which is about what people can do with the models, is about making sure the models don't do things that are unaligned with human intent. In other words, things that we don't want them to do. And secondarily and relatedly, how do we even know whether they're aligned with human intent, since they're so powerful and getting increasingly so they can deceive us? So that is sort of one aspect of it. People talk about it as alignment, as you may have heard, and it's quite technical and research-heavy in terms of how do we understand what models are trying to do. Then there's a question of what people can do with models, right? And people can do all sorts of bad things with AI, ranging from the immediate, such as creating disinformation and putting it online at a vast scale that we haven't seen before, executing fraud. So it used to be, and it's still the case, that fraud networks hire and often traffic thousands of people and put them in a basement in Southeast Asia. But now they don't have to do that, right? They can automate like every other business, so they can do fraud at scale with minimal cost. And these are the immediate, sort of more pedantic, if you like, risks. But then there's the frontier, more scary risks that have to do with powerful models enabling bad actors to do things in the bioweapon space, in cyber, in nuclear, conduct sort of very serious crimes. So that, I don't know, that obviously doesn't get you to a definition, but maybe a hopeful overview of the space of what we're concerned with when we talk about AI safety.
I think it definitely illustrates how multifaceted this is. You know, and I'm sure you have input also on the question.
I think it's very hard to define. But one way you can think about. I really want to make 2 points. So one way to think about is basically whatever the combination between the human and model can do, which is considered illegal in the context of the law framework in a particular country, right? Because the scope is what really matters. What is illegal here may not be legal in other countries, in another country, or the other way around. So I think that's one aspect. The other aspect, again, is that as an exercise, because we are talking about these LLMs, smart LLMs and so forth, you can think about, you know, it's like, because we call them all the time assistants, right? So you have a human and her assistant. And what that kind of combo can do is, of course, it depends on, you know, it's like the human, the kind of the advisor, you know, I'm talking in, you know, like I'm a faculty here. It's like it can give, you know, that tell to the student or whatever, to the assistant, to do the wrong things, right? So it's a kind of the advisor. Now the question is that whose fault it is, right? And it's basically in that case, if you can trace down, maybe the human is at fault by asking that assistant to do something. But in the court of law, it's not clear cut, right? Because did, for instance, the assistant realize that what was asked to do was illegal, right? And if that's the case, then also they're at fault. But I think that's kind of the way I try to think, because it makes it much easier, at least in my mind, because you have so many, you have a richer experience, you know, in this kind of thinking about, okay, it's the advisor is like and the assistant, right? But at the end of the day, it's if this kind of combo somehow is doing something which is illegal in the law framework of that particular country, and then that's a violation of safety, right? At least maybe it's not a sufficient condition, but it's a necessary condition. And then it's about assigning and whose fault it is, which I think it's probably complicated. And ideally, you want the kind of the LLM or the assistant, even if the humans wants to do something bad, to catch that up and refuse to do it, right? Which tries to happen. Yeah, but I think that's kind of...
Can I add a couple of points here? I think, Ian, what you said is very interesting, but I would push back and say being illegal is sufficient, but not necessary. So the opposite of...
This is what...
So imagine, for example, situations where a model, maybe you have in the future an AI boyfriend or girlfriend, right? And all of a sudden, the AI boyfriend or girlfriend starts pushing products to you, like maybe in a traditional sense, your girlfriend would say, oh, can you buy me this present? Now your AI fake girlfriend asks for presents, but essentially behind that is a company that is using that to monetize and make sure that pushes you to buy products that then the company can profit from. Is that illegal? Currently, that would not be illegal, but is it okay, right? Is it okay for us to be manipulated by AI systems beyond our control in ways we don't even perceive, let alone understand? Probably not. So there's a lot to AI safety that, although obviously things that are illegal are part of AI safety, but there's a lot more there, partly because the law has not quite caught up, which is a very important point in this space. We are called to create norms and think through problems and address them, with the legal system far behind in helping us out establish norms. Which gets to the second point about responsibility. So a really important discussion in the AI safety, AI ethics space is who's responsible for what? Now, there is an emerging conversation if models can be legal entities, right? If models can have some sort of personhood. But in reality, when we say the model is responsible, what we mean is that the company behind the model is responsible, right? But the company behind the model can be the model creator, the model developer, the model deployer, right? The product creator, or the user. So it gets extremely complicated to figure out who's responsible for what in this space, and is really what this conversation at the end of the day is about. Yeah. Allocating responsibility.
Yeah, right. I think in the general case, it's extremely complicated. I'm not debating that. I think that, though, in many cases, you can simplify it by analogy. Like, for instance, if I'm using a code assistant, still probably the most popular application besides conversational, the ChatGPT kind of application, who is responsible? And I'm not talking about safety, but accountable. Right? And the accountable there is not Cursor or someone else. It's accountable because when I write programs, the programs is going to have vulnerabilities because I click enter and I accepted the suggestion from Cursor or whatever other Windsurf and whatever coding assistant, then it's the developer. Right? The developer is responsible. Right? It's the company I'm at. If there is some problem in the code, it's not the assistant, right? It's a developer. So I just want to say that, well, I think I agree that there are cases in which, obviously, and it's very hard to tease this up, but in some of the other cases where these LLMs are really used as assistants and the human is supposed to be the ultimate arbiter about using that output from LLM in her workflow, in that case, things are a little bit more clear-cut.
Right. Yeah, fascinating back and forth on this, and there's so much to get to. I will try in 20 minutes. So Artemis, you mentioned how I think all model developers, or at least most, and users for that matter, of AI products, there are certain behaviors they don't want, right? I mean, models might be, even if they're not behaving in an illegal way in a country, they might still behave in a way that, the average person wouldn't approve of. Not to pick on you too much, ElevenLabs, your employer, right, doesn't have like the best track record in this area. You've had challenges there for sure, right? Last year, a user used the ElevenLabs platform to create, a deepfake of former President Biden, like a robocall, right? But I bring that up not to put you under fire, but because I think it could be a useful case study or kind of illustrate like the real world challenges that can happen, right, when things don't go completely according to plan. So maybe you can tell me, as like an insider, at ElevenLabs, a company that produces a range of, text-to-speech tools. What have you tried to do to prevent that kind of thing from happening? And where are areas that you think there might still be room for improvement, and for the broader industry as well?
Yeah, absolutely. It's a very good question. So this is a technology that can be abused and will be abused, right? There is no way that you can create safeguards that are 100% effective 100% of the time. And ElevenLabs is a pretty young company. It's only been around for about 3 years, right? So we're developing fast, both on the product and model side, of course. We have a new model coming out just today, which is very, very exciting. And on the safety side, right? So in response to the Joe Biden incident that you mentioned, which was about 2 years ago now, where somebody essentially cloned Joe Biden's voice and used it to call people in New Hampshire and tell them not to vote or something similar. In response to that and the general sort of safety considerations in the space, we've worked hard to develop our safety stack. So it's important to remember that in this space, there is no golden solution, right? There's no single thing that you can do that will work well all the time. What you need to do is stack guardrails. And the idea is that bad actors or unintended behaviors might get through some of them, but if you really built out a well-thought-through safety stack, then very, very few, if any, should be able to get through all of them and produce a harmful effect. So what does that mean for us, and what should that mean for responsible developers and deployers out there? The first important thing is to red team, essentially to conduct risk assessments and understand how your models and products can be abused, right? Because a lot of that is not immediately obvious. You're putting a great product out there in the world, it has all these exciting use cases, it helps people in all these good ways. You don't necessarily think about the edge case of the bad actor, the determined bad actor. So red teaming is very, very important. It used to be that red teaming is a very manual exercise of experts going out there and trying to break the model. Increasingly, we see a lot of automated solutions by third-party providers that people can tap into in order to do pretty cheap, effective, and quick red teaming. So you do your red teaming, you understand your gaps and your vulnerabilities, you conduct your risk assessment, and now it's time to build your mitigations. And there's a lot of options, and the key is prioritization and making sure that you have a theory of how they all fit together. And what are those, right? What are we investing in at ElevenLabs? For model developers, there's a post-training layer where you can sort of teach the model to respond to requests in a way that's ethical, in the way that's intentional. And that's a lot of what the traditional sort of safety work in the big labs, right, like Google and OpenAI and Anthropic is about, is people post-training the model to get it to respond in appropriate ways. But there's a lot more that happens downstream from that the space is starting to develop. There's things like creating a detection architecture, using AI itself to figure out when your model or your product is generating bad results. So building out your detection architecture with classifiers is the next step. Then putting in place a monitoring system and making sure that you both block bad generations for your users, but also punish or remove users from your platform that are consistently behaving in undesirable ways. This KYC, this is something that has received relatively less attention in this space, in my opinion, relative to how useful it could be. Know your customer. The financial industry has leaned traditionally very heavily on know your customer sort of provisions to do things like cut out bad actors that would engage, say, in money laundering, right? So the AI industry can adopt similar models to weed out bad actors that use models in undesirable ways by doing screenings of its customers upfront. Another thing, like product-level mitigations are really useful because essentially they provide safety by design. So one thing we've done at ElevenLabs, for example, at the product layer, is introduce voice verification for certain use cases, and especially for high-risk actors, where you have to prove that you're the owner of the voice by passing essentially a voice check. And then only if you pass that check, you're allowed to clone your voice. And then there are things like provenance, inputting watermarks or metadata in the output so people can trace back the provenance of that piece of content to whoever created it. So all of this together create a complicated safety stack. And we're very excited at ElevenLabs to build that out and continue maturing it to make sure our products remain safe.
Right. Now, it does sound like, you've been thorough in the stack, but I wonder, is that possible for every model out there, right? There are plenty of open models, text-to-speech, right, that you can use pretty much without safeguards. I mean, I've used some of them for voice cloning. Like, it's shockingly easy, I think, to create like a really high-quality voice clone now. Like, there are many models to choose from that are pretty good, right? So what would you say about those models then? Like, are there, how do you go about building like a safe, like open model for this sort of use case, right? It seems to me to be like a very challenging thing to do, to balance, okay, you want a good model, right? You want it to perform well and users to like enjoy it and like it, but you don't want to enable bad behavior, right?
Sure. I mean, that is a difficulty in this space. So before working in AI, I used to work in social media. I did similar work. So I worked at Meta. So if you kick bad actors out of Meta, they can't easily go somewhere else. I mean, they can, but they lose a lot, right? Like, it takes them time to build their audience. It's obviously a platform with very wide reach. So you have a lot of power as a company to weed out the abuse and make sure that actually, stays out. But with AI, it's a lot trickier, right? Because as you point out, if you're a single company, you kick out people from your platform, okay, that's great. We've done all this work at ElevenLabs to make sure that happens. But then what if they go use someone else's model, or even worse, an open source model? Well, there are a few things that can happen there. It's not entirely hopeless, and I'm sure Ian will have good ideas as well. First, there are guardrails you can put even in open source models. So it's important that open source models developers also incentivized and sort of made sure that they put guardrails in those models. However, they can be removed, right, if you're using an open model. People that host open models, like Hugging Face and other providers, they can also do a lot of the things I talked about earlier, like screen their customers and only give access to open models under certain conditions. And finally, this is where you need standards for the space through a regulatory approach, right? Because maybe it is the case that certain open models should not be used, or that certain uses should not be allowed. And that's where you have to regulate use at an ecosystem level.
Again, I want to say two things here. So the first thing is that we need to learn about where we have about the safety security stacks in other domains. And if you look in the software, you have very similar things, right? You have good practices about writing a program, like checking the input length, right? Because you use it in a function. Then you can have different ways of testing. Of course, you have unit testing, but then you have fast testing, automatic testing, static analysis, right, to detect kind of the vulnerabilities. That's another one. Then you have a stack, right? You have firewalls in a networking, right? In front of your application and things like that. Then you have red teaming, as well. And then what is important, and Artemis mentioned, is about the detection mechanism and remediation mechanism. This is really very important because it's maybe impossible to figure out from even it's a software which is much simpler, right? Because it's more of a white box, at least from the point of view of the developers, than the line language models. Is that some bad things will happen, right? Zero-day vulnerabilities, right? And you need to answer right away, right? So that kind of mechanism. So it's both about not only about the development phase and so forth, but also the deployment and how you are going and how effectively you can provide remediation and so when something happens. Which also this means that you have to also have extremely good tools in detecting when something bad happens. If you don't know something bad happened, then forget about that. And you go even one layer higher, you have certification, like for companies and so forth, like SOC 2, Type 2, and all of these FedRAMP and things like that, which add the different layers to make sure that these companies, you don't have bad actors, right? Because that's very important. You see all these studies and say security vulnerabilities, where they come from. And you see all those statistics that actually many of them, in many cases, majority, is internal attacks, right, from people or negligence, right? So it's a very, very broad. The second point I want to make is about the open source. When we talk about the open source model, we are thinking about the open weights. Only the weights are open source. But I think that the true interpretation of the open source AI, open source models, mean open source data, open source training code, open source weight, open source evaluation. So you need to have all of these things. And this is important because if you have open source data, right, and open source code, you can have some trust in weights, right? More trust. Like for instance, since there are all this kind of publication about how or anecdotes. You ask an LLM, how to build a biological weapon and so forth, and the answers, right? Because probably somewhere in its corpus of data there was this information. But for instance, when we teach college, as a college students, right, we don't teach them how to build a bomb and so forth. That's kind of, like that kind of information is not something we teach them, right? It's like, of course they can find from some other places.
But I don't know what you guys are up to. I've heard.
But
I've
what
heard
I'm trying to say, by controlling the data, you are going to teach, and this kind of to be open provides an additional level of insurance. Nothing, and then if you do that, and if you can, you can inspect the weights and so forth, then you can make the model, and you can cryptographically check and so forth to make sure that this model and these weights are used to serve a particular application, right? But I just taking a step back, look, it's really a complex problem, and the reason I make the analogy with the software, because the software, which is supposed to be simpler, because artifacts you are building in software are simpler, less general, are less black box. Even in that space, you have a huge like in terms of architectures, a huge processes, certifications, right? Ecosystem to protect this kind of software artifacts. So think about, this large language model. It's even much more complex, but we still need to, learn some from these best practices, which we developed over decades, and see what works, what doesn't work. We don't need to reinvent the wheel every time.
Right, right. So I think a lot of what you talked about just now is, it gets back to this idea of transparency, right? And I think at the top, both of you touched on kind of benchmarking, right, and red teaming and ways we can, try to ensure that models remain safe, perform as expected. But as we both know, like benchmarking is a tough thing to do, right? I mean, the benchmarks that we have in the industry, they're good in some ways, maybe lacking in others. I mean, Jan, like, one of your many projects is LM Arena, right? And, somewhat recently, there was an incident where, maybe I should be letting you explain the premise of LM Arena, but I'll give, just a brief overview in the interest of time. It's a if you're not familiar, it's a crowdsourced benchmark where you can go on the site and basically you get two outputs from two different models. You don't know which models those are. And you can thumbs up an output, and then that vote contributes toward a model's score, more or less. I hope I'm on the right track. And the models that score the best rank toward the top of the various leaderboards on that site, and models that don't do so well do not. But a while ago, Meta submitted a model that they later revealed was not a version of the model that they released publicly. So the outputs on LM Arena were different than the outputs you would see from the model that you could download at the time, right? So I bring that up because not only is benchmarking hard to begin with, but sometimes, not every actor is, being fully transparent about their practices, right?
Totally, and I can add a little bit more light on that. So in that particular case, by the way, we have a policy on Chatbot Arena, and the policy says that we are only going to show the public rating of a model only if it's available to other people for use. It's publicly available. It can be in one or two ways. One, it has a public API, so you can use it. This is proprietary models. Maybe in exchange, you pay a fee for that, but it's publicly available. Basically, everyone can use it, at least in the US. And the other one, it's an open source model, right? And on the open source models, we assume that it's available the way it's available. So then you can yourself, if you want, you can use and serve it. So that's kind of the policy. And I think in this case, what happens is that the model which was shown, and typically we don't serve ourselves the open source models. We have the people who develop the open source models, like Meta and so forth. Also, they provide an endpoint for us to use that model. So in this particular case, it was, we have the endpoint, we evaluate it, we show it on the leaderboard, but it turns out that they eventually didn't release that model. Right? So in some sense, that was inconsistent with the policy, but it took time to figure out, right? And there are people, trying it. They say, hey, like I'm trying this, what you released, it's not as good as this one here, right?
Yeah.
And eventually we took it off. But it's to your point about the transparency. Some of these things are very hard to check because how can we know that? It's like we don't know for sure, right? I think at the end of the day, also to look on the positive side, the fact that Arena was open and people is in some sense is kind of transparent how we compute the rating. Actually, we also release when there was people was kind of saying, this cannot perform so well. We release actually the data right before and then people look, but when I try this thing, it's not giving this kind of answers. So I think that's kind of a very important aspect. And then there are also these other aspects about evaluating this model is extremely complicated, like evaluating people. Right? It's very complicated because, like for instance, there are people, it turns out that the format of the answer, whether the tone is funnier or not, you have more emojis. Right? Actually, this is one of the things about this model. They show more emojis. And people say, okay, it's like, you can be fooled. But the truth is that we as humans are fooled by other people. If someone has a much better presentation, much nicer slides, it's speaking more articulated and things like that, we are impacted, right? So now the question is that yes, and then can you tease out this kind of bias, right? And in some sense, the short story is that if you have enough data, and enough diverse data, and you know that there is a bias, you can actually, factor that out, right? But again, the question, do you know what the bias is, right?
Right.
I just want to add something here. I think what you point out is an interesting kind of instance, right, or use case of gaming the system. And there is a general problem in metrics, right? Like even if you're honest about it, you always sort of end up gaming your own metrics because you're overplaying to the metric you set out, which is always a proxy for reality as opposed to directly the thing you care about. But there's another, maybe in my opinion, more fundamental problem about transparency and metrics in the space, which is nobody can agree on what are the right metrics, right? If you have a proliferation of standards, you even have standards at the end of the day. Like a standard by definition is something that everybody kind of aligns around. And it's extremely difficult, and you touched upon it, to figure out what are the things that we care about, how do we define those things, and then based on that kind of measure model performance, right? Measuring the model's performance in some ways the least difficult problem in that context. For example, you mentioned the word bias, right? So people use the term bias to mean very different things. For some people, bias is everything that is not exactly between a conservative and a liberal position, right? Everything that's not exactly completely neutral vis-a-vis conservative liberal positions. That's one definition of bias. Another definition of bias is things that are like have some error in factuality, right? So they're like somehow incorporate facts that are not true. Other people have a higher aspiration of being somehow objective, right? Of interpreting reality in a way that's unassailable. These are different definitions of bias, and nobody can agree on what the right one is. Ultimately suggesting maybe people are biased as to their very definition of bias. So if we can't agree on these fundamental prior definitions of what are our values and how do we define them, how can we ever hope to have alignment on particular tests that will guide us on what models are safe or models are good or not?
Totally. Right. In this particular case, the bias was with respect to accuracy of the answer or the completeness of the answer, right? Basically saying, hey, this answer maybe is not as complete and maybe even kind of wrong, but people are going to prefer it. And by the way, it's like it's a fun stuff. When you're looking, actually, because early on, when we try to evaluate, in order to scale, we use LLMs. We are one of the first to use this LLM as a judge to evaluate this answer instead of humans. And we we make this, and we look at the study then about in terms of kind of agreement between the LLMs and the humans, and they are doing this. And when you did this study, first of all, we saw to our surprise, maybe we shouldn't be surprised based on what they are trained on, which is things from people. The LLM has the same kind of biases, and I'm saying, it's like position bias. This means they prefer everything being equal, the first answer. Verbosity bias, they prefer everything being equal in terms of the information in the answers, the more verbose answers, right? You have some kind of self-bias. They prefer the answers from other model from their own family, right? And at that time, this was 2 years ago, they were pretty bad in kind of trying to figure out, like, in kind of the math and so forth, to try to, to grade this kind of math answers. So, that's kind of, even this large language model has a bias, but you are absolutely right. You have to understand and you have to define what bias means, what overfitting means, all of these things, which are used, in a pretty, I am using in a pretty loose way.
It's almost a sweet thought that models would prefer models from their own family.
Yeah,
Maybe that says something, something good about
right.
AI world.
Well, I think we could talk about this all day, but I believe we're at time, maybe even a little over. So I want to thank you again for coming, and thanks everyone for enjoying the talk with us. We'll head that direction.